Hello and welcome back, everyone. So this is the next video in our series. I will be discussing a couple things today. So first on that list is a disclaimer, really. What I'm going to do is I'm going to be walking us through some of the AI models that I use using Python scripts and the Transformers library. Now, this is not going to be something that explains what's going on in pipeline or transformers or whatever part of it you want to use. I'll be using an encoder and a decoder, all of that fun stuff. If that is an issue, then you might get a little confused in the middle portion. But working through that, I'm going to go ahead and show you guys first. I'm going to go in and clean up some of my models. Just so it looks a little better in VS Code. And then next I will walk through a text model. So I have a Python script that will ask an AI essentially how to answer a question. And then after that, will go through a picture model, a diffusion model. I'm not exactly sure which model I want to use at this point, but I'll show you one at the very end. So let's go ahead and get started and switch over, and I'm going to walk you guys through cleaning up some of the stuff that we have left over from the last videos. Okay, so here we are inside of the container for Ubuntu. This is a WSL2 inside of Windows. So what we're going to do is we're going to go ahead and clean some stuff up. So first thing I'm going to do is ls, and we're going to go into the code directory. Inside of there, I am going to make directory, and what I'm going to do is make a file called Docker files, and then move gpt.dockerfile into do/code/Docker files. Whoops. It helps if I spell correctly. Docker file. Okay, and we will do the same with the picture Docker file. Perfect. And then we are gonna make a directory for AI models. And here I will house my Python code. So what I'm going to do is I'm going to make a directory for the AI models, and there it is. And now we are going to do our favorite thing, code dot. I'll go ahead and bring this over. So now we have Docker files in here. I like to do this just because of the way that I prefer to keep my VS Code looking. I think it looks easier to use. So inside of here, we are going to make a Python file. So solar.py. This will be a way for me to load this in here. Okay. So here we have, let's go ahead and save it. I believe you guys might benefit from it being a little bit bigger. So, yep, that looks good. Now we're going to import time, which is just a module that will keep track of the time for us down. Torch, which the tokenizer model needs. And then from transformers, the auto model for a casual LM and auto tokenizer. Normally, I do the entire transformers and use pipeline, but today we're just going to go ahead and use it this way. So the first thing we do is we get the tokenizer. So this is the tokenizer from the pre-trained model Upstage Solar 10.7b Instruct V1. We will then grab the model from that as well. This will allow me to offload everything that doesn't fit on my GPU into my CPU. You'll see when it's running later that it will actually say some of the parameters have been moved off of your GPU. I do not have a big enough GPU to run this entire model, and I'm not using any quantization methods. So no GPTQ, which is what I normally use, or anything like that to make it smaller and run entirely on my GPU. Now, the conversation part, what we're going to do here is we have role system. So essentially what this means is it's sending a message saying that the system knows, or the system is being told that you are a chatbot that will come up with creative answers to the question asked. Now, then the role of user, which is us, is going to ask the question, French fries or curly fries? I made this up on a whim a long time ago, and I kind of like the answers that the AI model gives me because it asks for a little bit more creativity, and honestly, it's just kind of funny. So then we are going to take the prompt and we're going to make the conversation, tokenize all of this, and apply the prompt template to the conversation. And then inputs will be tokenizer, and then prompt, return tensors, to model device, outputs equal model generate inputs, just that, cache, and then I give it a max length of 4096. The output text will be tokenizer decode outputs. So that will decode the outputs that come into it. So there's a really good video that I will link in here that explains everything that happens. But essentially, you take data, information, words, you add it in, you encode it, you throw it at this model, and then you get what it comes out as, and then you decode it back. Essentially, think of translating. It's kind of like it translates it from English to Spanish. The machine works in Spanish, and then it translates it back from Spanish into English so we can read it. Obviously, that doesn't work if you speak Spanish and English, but just think of it that way. Instead of Spanish, it's the machine language. So that's a really, really generalization, but you get the point. This isn't technical. Up here, we have start. So I have a time. This will start here and will end here, giving me the total time that it took for this process. We will then have duration equals end minus start. And it will print out two things for me. It'll print out this operation took blank seconds in integral, not float. And then it will print the output text, which is the decoded output from the model, or at least the first block of the decoded output. So let's go ahead and save this, and we can X out of here. Let me see if I can actually do. Oh, not what I wanted to do. Let's see. 1 second as I delete all of this. And then what we are going to do is we are going to take that and move it into the Docker file. So this is still on the Ubuntu WSL environment. We need to take this and then run it over to the Docker file, and then we'll open up that container and run it inside. Just a little bit longer. Okay, so now we will do Docker container ls. You'll see I exited it 24 minutes ago. So what we will do is cd AI models, and then we will do Docker CP. So this copies it from the current directory. So we will copy solar.py. If you are using a part in a different folder, you would put the designation here. But since this is actually in our current working directory, I just need to put that. And then we will put GPT container, which is the name of the container we're going to put it into. And then home derp, which is the user. Okay. Let's try. There we go. Now Docker start -i. Okay. logged into root. Let's log into our user. So here we are. The file is already in there. So let's go ahead and we'll just keep everything there. So now we are going to do Python 3 solar.py, and this will go ahead and start to run it. What's going to happen is it's going to load the checkpoint shards. I actually downloaded it earlier, recorded something, and I didn't have a mic. So what it'll do if you don't have it downloaded is it'll look, if it's not on your system, it will go and start downloading all the checkpoints that you need and everything you need to run the model. Now, for me, since I have that, you'll see warning, some parameters are on meta device because they were offloaded to the CPU. I don't have a big enough GPU to run the entire model. It is, roughly 5 times 5, so 24 something gigabytes. I only have 12 or 18, I think I have 12 gigs of VRAM on my graphics card. So some of it was offloaded into my CPU and will be run on RAM as well. So let's go ahead and pause here, and I will come back when it is done loading, and we'll even have the time. Okay, welcome back. Now, what you can see here is, so the way that I have it set up, it will say everything. So this is what it was given. The system, you are a chatbot that will come up with creative answers to the questions asked. Well, question. The user input was literally just French fries or chicken fries. Now, the answer is, as an AI, I'm not capable of personal preferences, but I can provide you with an imaginative perspective. Instead of choosing, how about creating a fusion dish that combines the best of both worlds, introducing French fried chicken bites. Now that sounds very delicious. And honestly, I kind of wanted to try it the first time I had this response come out to me. Now, I will say, since we are using the same model and I've been using the exact same words, I've actually had this exact same answer every single time. The reason that is because I have it set to be very, very accurate. So it won't try creatively coming up with something just in the way that I set up the model. Now, that shows all of it. And this took 136 seconds. So just over 2 minutes. So essentially that was able to do all of that. Now, if I had a bigger processor, or if I used a smaller version of the model, also known as quantization, or I guess it's not smaller, but it's just a quicker and less, it's less accurate, but it allows less space for less accuracy. So you're not getting your most amazing answer, but you are getting a good enough answer most of the time with some of these quantization models, but you can run them faster because they will be, or at least I can run them faster, as they will all be entirely on my GPU level. Now, I'm going to go ahead and pause and bring up a picture model for us, and then I will show you how to do this, which is going to look very similar with the picture model. So, small change. I will actually be putting in a break here because I do not have the ability to have 15-minute long videos, or really anything over 15 minutes, and this video went too long. So, what we're going to do is go ahead and wrap this video up, and then I will start again on the next video and show you guys how to run the picture model, and then we will be done. See you then.